Hello everyone, today I'm going to present about sentiment classification using some machine learning techniques. Using movie reviews as data, we are concluding that the standard machine learning techniques definitely outperform some human-produced baselines. A challenging aspect of the problem seems to distinguish it from some traditional topic-based classification. While the topics are identifiable by keywords alone, sentiments are expressed in much more subtle way. Introduction. Very large amount of information is available online. Investigating of the problem of text categorization is important. There's an increase in online discussion and review sites that contain sentiments and overall opinions towards various subject matters. For example, whether the product's review is a positive or negative. Here are some examples of some famous social media sites like Twitter, IMDb, Amazon, and Reddit. From these websites, we can get much more information regarding product reviews and movie reviews. There's a sentence, how can anyone sit through this movie? This is a movie review. This sentence contains no single word of negation, but still it implies that this sentence is conveying an obvious negation. These type of sentiments require much more understanding than the topic-based classification. For classification, they have chosen to work with movie reviews dataset. The data source is a famous website called Internet Movie Database, also known as IMDb. The reviews with author ratings expressed in stars as well as numerical values which were used in order to get the estimation of the outputs. Here, ratings are automatically being extracted and converted into some positive, negative, or neutral value. For this paper, they are specifically chosen to work with only positive and negative reviews. For testing purpose, they asked some of the students to come up with some good indicators which rely positive as well as negative sentiments. Here are some examples of the students that choose positive words such as dazzling, brilliant, phenomenon, excellent, etc. Based on this, they choose an average of 7 positive and 7 negative reviews. Here they have used three standard algorithms, basically naive Bayes, maximum entropy, classification, and support vector machines. A naive Bayes classification assumes that the presence of a feature is unrelated to the presence of any other feature. That means that no feature is interrelated to any other feature. Despite its simplicity, the fact that its conditional independence assumption clearly does not hold in the real-world situations. Thus, naive-Bayes text categorization still tends to perform very well. Maximum entropy is an alternative which has proven effective in many natural language processing applications. Here, the functions might fire if and only if the bigram still heat appears and the document sentiment is hypothesized as negative. Maximum entropy makes no assumption about the relationship between the feature and so might perform very well when the conditional independence assumption are not met. Here they have used 10 iterations of improved iterative scaling algorithm for parameter training. Support vector machines have been effectively in traditional text categorization. For this, they have used GeoGebs SVM Lite package for training and testing. They have not given any specific parameters for this experiment. In the two category case, the basic idea with the training procedure is to find a hyperplane that not only separates the document vectors with one class but also has a separation as large as possible. Coming to the dataset, they have randomly chosen 700 positive as well as negative sentiment documents, further dividing into three equal size folds, maintaining a balanced class distribution. The classification accuracy resulting from these unigrams as features was way better than two human selected unigrams of 58% and 64%. On the other hand, the topic-based classification of all the three classifiers on the unigram feature was around 90%. This provides a suggestive evidence that sentiment categorization is much more difficult than topic-based categorization. Here is an example of a movie review data. Movie review: a good 60s film but lacking any sense of achievement. A unigram is a single word in the sentence, such as good, 60s, achievement, lacking, etc. A bigram is a combination of any two unigrams in a single sentence, such as a good 60s film, any sense, etc. Trigram is a combination of three unigrams. Example: a good 60s, sense of achievement, any sense of, etc. A fourgram is a combination of four words of a sentence or a review. A 60s film but lacking, etc. Here are some experimental results which they have shown during their experiment. They have chosen to work with unigrams, both unigrams as well as bigrams, bigrams, single unigrams, as well as position of a sentence, adjectives, and various others. There are a number of features that they have used in this experiment. They are basically focused on the frequency or the presence of a feature. Frequency means how many times that particular unigram has occurred in a review, and the presence only checks whether that particular unigram is present in that specific document or not. Presence would work for this movie review, as we only need to focus on the presence of the feature rather than the number of times it has occurred. They have also shown the accuracy of each of the model related to the features they selected. From the diagram, we can easily conclude that SVM works very well with unigrams taken into consideration. Observations: maximum entropy feature or class function only reflects to the presence or absence of a feature, as we discussed earlier. They binarize the document vectors by setting n of t to 1 if and only if a feature f is appearing in a document. For example, if a feature good is appearing in a movie review, then they increase the value of that particular review by 1. Much better performance for the SVM is achieved by only accounting the feature presence and not the feature frequency. Adding bigrams does not that much improve the accuracy beyond a unigram's presence. Relying just on bigrams decreases the accuracy by 5.8% compared to the unigram. Part of speech tags serves as a crude form into a word sense. For example, love in I love this movie and this is a love story. Those both are different sentences, have a different meaning. Here, the former gives a much more positive sentiment compared to the latter that has a neutral sentiment with respect. The accuracy also improves slightly for naive-based but decline for support vector machines. Adjectives might also add a great deal of importance regarding a document's sentiment. They tried with adjectives too, but the results are relatively poor for those. Thus, they concluded that the adjectives provide very less information than the unigram's presence. Position. Position of a word is where it is occurring in the text file. For movie reviews, they might begin with overall sentiment followed by the plot discussion and concluding what summarizes the critic's view. For this, they tagged each of the words according to whether they appear in the first quarter, second quarter, or in the end of the document. The results did not differ too. Here is the conclusion of the paper. The unigrams turned out to be much more effective, thwarted expectations, where the author sets up a deliberate contrast to the earlier discussion. For example, this film should be brilliant. This whole sentence is a movie review. Here we can see that the that there are many words such as brilliant, great plot, first grade, good, good performance are positive in a sense, but at the end it can't hold up is a sentence which describes about the whole review. Thus, a human can easily detect the true sentiment review, but a bag of feature classification would find these very difficult since there are many words which oppose sentiments to that entire review. Thank you.